example 1, they ask if d minus 4 is actually a factor. There's two ways that we could do this. We could actually factor this and check. So if I was actually factoring this and check, I know that there was a 2 in common. I would pull that out first. And then, since there's a 2 in common, and I need to factor the rest of this, the only way to get d squared would be d and d. And 28 times table. What two things multiply 28? 7 and 4, 14 and 2, 28 and 1. Now, of those ones, I need my outside and my inside to make 3. So I'm going to go with 7 and 4, because 7d minus 4d would be 3d. So I would need my 7d to be positive and my minus 4d. So if you factored it completely, is d minus 4 a factor? Yes. However, in a question like this one, this is another way that you could do this question. If you were checking if d minus 4 is a factor, well, if one of them is d minus 4, and this is what I started with, does it make sense that the only way my first one would be 2d squared is if I had a 2d there? And the only way I would get negative 56 is if this was plus negative 4 times 14. And then I'd have to check, does it actually work? And if I multiplied it out, d times 2d, 2d squared. d times 14 plus 14d minus 8d minus 56, 2d squared plus 14, combine those like terms, plus 6d minus 56. Does that match up? Yes. So if they give you one, you can actually check it much quicker. Okay? Now, as far as factoring completely, this right here in the green box is considered factored completely. This in the orange box is factored, but not factored completely, because this last factor in blue still has a 2 in common. If I pulled out that 2 in common, I would still get the d plus 7 that we do in the factored completely one. So do we have to take the common factor out first? No, but it's nicer when you do. Now when we go to b, 3d squared, I'm going to do this in both methods as well. But I think the second method is easier, so I'm going to start with that. So if I was using the second method, I would say, well, one of them is d minus 4, then the other one, in order to get 3d squared, would have to be a 3d there. That's the only way I'd get my first ones to be 3d squared. And if I had a minus 4 here, and I wanted a plus 4, this one would need to be minus 1. That is the only possibility to get the first ones to match up and the last ones to match up. But when I actually multiply this out, 3d squared minus d minus 12d plus 4, I get 3d squared minus 13d plus 4. Does that match up with what we started with? No. So in the method 2, if it is a factor, it tells you what the other numbers would have to be. And if they have to be 3d and minus 1, then if you multiply it out, it would have to work. This one didn't work. Using the other method, we would actually factor it. The only way would be 3D and D. To get 4, could be 1 and 4, 4 and 1, or 2 and 2. And we need our outside and inside to make 13. I hope that you see that a 4 here makes my outside 12, and a 1 there makes my inside 1. 12 and 1 is 13. If it needs to be positive 13, I would need a positive 12 and a positive 1. Is D minus 4 a factor? No. So circle questions 7 and 8. But we're going to do one more example first.